Okay, so today is week 11's online TA class, and I'll begin in a few minutes. I'll just allow a few people to join. And until then, if you have any questions, please post in the chat. Okay, so we can start the class for today. If there's a question which you want to ask or which you want to discuss, then please let me know. I will discuss your questions first, I think, and if not, then I will just continue with the class. Okay, so today we're going to discuss profit maximization, and the first question is a very simple diagram. The diagram shows the relation between the marginal cost curve, the market price, and quantity. So in a perfectly competitive market, there's the firms tend to be price takers, right? So we are assuming price to be exogenous. That's what it means, that the price is not determined by the firms, but the firms are price takers. So in a perfectly competitive market, you have a diagram of this sort, where the marginal cost curve is as shown in the diagram, and the market price is represented by P star, which is shown on the diagram with the green horizontal line. Okay, so the market price is a horizontal line because the market price is fixed. The market price is not changing by the firm's decision, which is essentially what happens in a perfectly competitive market, right? So the question is asking, at which point does the given firm in this market maximize its profit? So that is the question. And I will allow you to think for a few minutes before we discuss the question. Okay, so I will discuss the question. So there are 3 points marked on the diagram, which are represented by the quantities Q1, Q2, and Q3. And the price in the market is the same. It's constant at P star. The marginal cost is varying as shown in the diagram in this dark blue colored curve. So we have to determine at what point is the firm going to be maximizing uh, its profit. So let me just redraw the diagram here so I can explain. So this is question 1. So let's say this is the marginal cost curve and this price line is P star. At this point, the first place where the P star line is intersecting the marginal cost curve is the point at which quantity is Q2. This lowest point of the parabola is quantity Q2. Oh, sorry, that was Q1. This is Q2. And the point where the price line is intersecting the marginal cost curve again is the point where quantity is Q3. This is marginal cost. So this is the question. I'll just repeat the question for the benefit of anyone who's not heard the question. the question is asking that in this diagram, which I've just drawn, at what point is the firm going to maximize its profit? So at what point will the firm be operating? So the firm is obviously going to operate at the point at which it's maximizing its profit. So that is the wording of the question. So let's look at what is happening in this case. Now, if we talk about the first point in the diagram, which is Q1, where quantity is Q1. At this point, the firm's marginal cost is equal to P star. But if the firm thinks that, let's try to increase the quantity, then what happens? The marginal cost is decreasing beyond that point, right? So in this whole area, or let me do it this way. In this area, where I've just marked this blue thing, in this entire area, as the firm keeps increasing the quantity, its marginal cost is decreasing, right? Marginal cost is less than the price. So it will go on increasing the quantity because the firm will go on producing until it is actually making positive revenue, positive profit, sorry. Right now at this point where Q3 is the quantity and the marginal cost is some value here, this point. At this point, if the firm increases the quantity any further, the marginal cost is higher than the price, right? So beyond this point, if the firm wants to increase its quantity, it is not going to be making profit, right? So if I were to explain it in a different way, let me highlight that part. Now, if on this diagram I want to represent the profit of the firm. Profit is what? Price minus marginal cost into quantity. So price minus marginal cost is this blue area curve which I have just depicted here. If you look at it in this way, it will be clearer. This light blue colored shaded part, that part is the price minus quantity in price minus marginal cost into quantity. That is represented diagrammatically. The rest of the part, this part, which I'm shading in green, is the part which represents profit of the firm. And why is that? Because this is the part which is representing the region P minus MC into Q, right? Use a different color. This area, this area is P minus MT, or you can say P star minus MT into Q, which is profit, right? So only in this area can the firm make positive profit. Beyond this, if the firm increases its production here, if it increases the quantity beyond the point Q3, then this is excess. Right. Let me put it. In this area, this is the cost. This is the cost which is much beyond the, like, it is much beyond the price, right? Marginal cost is above the price curve, which means P minus MC is a negative quantity, which means the firm is going to go in losses. This whole thing is the cost, okay? This whole thing is the cost, and the revenue which the firm is making is this much, the pink area. I don't know if it is easy to understand. I'm just trying to show it diagrammatically because this is a very simple diagram. There's nothing else. No other information is given in this diagram. So if you see that blue, this is like cyan, this is light blue color. In the point beyond Q3, the whole blue thing is cost, whereas the revenue which it is getting from selling the good is only the area under the price line, which is, I've shaded it with pink. That means the costs are much, much more in excess of the revenue it is making. Therefore, the firm will not increase the quantity beyond Q3. So at point Q3, the firm is making the whole thing as profit. This entire green shaded area is the profit of the firm, right? And the firm tends to go on increasing its quantity until it can actually, it reaches the point where increasing quantity any further is going to lead to losses, because the firms will always increase the quantity till the point where they get the maximum, because it's not that you're getting profit only at that point. The entire region is your profit. I hope I'm making sense. So let me come back to the way it was. So this is the answer basically. So firm increases quantity till the point Q is equal to Q3. Beyond that, total cost is greater than total revenue. Therefore, firm is maximizing profit at Q is equal to Q3. Now, if I were to explain this using calculus, what I would say is that, when you solve a problem like this, you will get two values of Q, for example, for which, the first order condition will be 0, right? When we solve using calculus, we take the function for profit, and we take first order derivative with respect to Q, then we maximize it, we set the first order derivative equal to 0. When you do that, you will get two values of Q for which that function will be 0, right? And only one of those two values is giving you a maxima. Now, in this case, it is going to be for the value of Q equal to Q3 that you will be getting the maximum, right? So now if you're given some function in, like, if it's not a diagram, if you're given an actual function for the marginal cost curve and you're asked to determine at what point will the firm operate and at what point is the firm going to maximize its profit, then if you're getting two values of Q for which the first order condition is 0, then you're going to check which of those 2 points is a maximum, because both cannot be the maxima, right? One must be the minima and one will be the maximum. So here you can see that Q1 is actually the point at which the firm is starting to increase its profit. Like before the point Q is equal to Q1, the firm has no incentive to operate because marginal cost is greater than the price, which means the total cost is greater than total revenue. So it is not going to operate at all before Q1. Only after Q1, the firm even has a reason to operate. And after Q1, as it goes on increasing its quantity, its profit goes on increasing until Q3. So Q3 is the point of maximum. Okay, I hope that is clear. So the correct answer will be Q3 in this question. So is that okay? Can I go ahead?
Madam, in this case, it was slightly difficult to visualize using calculus.
Okay, if you're not getting it using calculus, you can forget it. I was just adding that as an extra mental note for you to keep in mind. If I find an example like that, I will share it. But like generally in calculus, you get only one value of Q, say suppose, and the function is maximized for that. So that's why I was just giving an added note on that part. But if you don't get the calculus part, forget about that. Diagrammatically, if you understand, that is enough for now.
Okay, madam.
Yeah. Okay, let's go to question number 2, which is still referring to the same diagram. In this, they're asking for the same firm as Q1, as question 1, which of the following are true for its profit maximization? So P is equal to MC marginal cost at point Q2 at point of profit maximization. P is equal to marginal cost at point Q3, Q equal to Q3 at point of profit maximization. So this we have already figured out. P is equal to marginal cost at Q3 because it is operating at Q3, right? So this relation will hold. P star or P is equal to marginal cost at Q3. So step B is correct. Then it's asking P is equal to average variable cost Q3 for profit maximization. And the next is P is greater than or equal to average variable cost Q3 for profit maximization. And the last part is P is greater than average variable cost at Q2 for profit maximization. So in the case of this diagram, which we have here, as you can see at point Q2, it is not maximizing the profit at all. So the last option E, okay, screen is not updating. Yeah, at option E, uh, P is greater than average variable cost at Q2 for profit maximization. It doesn't make any sense because firm is not maximizing profit at Q2 anyway, right? So E is also not correct. Now, question is between C and D. Right now, for profit maximization, the P is equal to average variable cost Q3. Now, this I think both could be correct because generally it is going to be, marginal cost is equal to average variable cost at that point Q3, and it could be that that is the point at which the average variable cost curve is intersecting the marginal cost curve, or it may not be. Or let me explain what I mean by that. Oh, sorry. I don't want to mess up this diagram, so let me just draw this again. Okay, so let's draw the marginal cost curve, something like this. And this is your price line. This is P star. So marginal cost. Now let me draw the average variable cost curve. Okay, so say suppose the average variable cost curve is just taking some example which is interesting. Yeah, so average variable cost can be something like this. Okay, say this is average variable cost. Now you can see that the average variable cost is intersecting the marginal cost curve at this point, whereas what we got given is this is Q3, this is Q2, and this is Q1. So this, let's call this point Q prime or something, so say Q prime. So at the point Q prime, marginal cost is equal to average variable cost, but it is not equal to P star, right? Now at the point Q3, where the firm is actually maximizing its profit, marginal cost is equal to P star, but average variable cost is something lesser, which is how it should be, right? So at the point of profit maximization, the marginal cost should be greater than or equal to average variable cost, and it should be equal to the market price, which is why, like, the question was asking. So for, let me write this down. For profit maximization, marginal cost should be greater than or equal to average variable cost. This is necessary, right? This is important. If this condition is not being met, and P can be greater than or equal to this, we can add this also. So basically at this point now you're seeing that in this diagram which I have drawn arbitrarily, average variable cost is intersecting marginal cost curve at some point Q prime, right? Now if this Q prime were equal to Q3, then you would have this condition. If Q prime were equal to Q3, which means if the average variable cost curve intersected the marginal cost curve at the exact same point where it is also intersecting P star, then you would have marginal cost equal to average variable cost equal to P star. But otherwise, you will have marginal cost equal to P star greater than or equal to average variable cost. Or we've already included the equal to case, so let's just say greater than average variable cost. So this is like the general conditions which I'm talking about. This is the average variable cost curve is not given to us. I've just drawn it arbitrarily. Now let's consider one more case. Say suppose I draw the average variable cost curve like this. Okay, I'll delete this later because I don't want to confuse you. But like if say suppose this is the average variable cost curve, prime, let's say, or let's call this average variable. Say suppose it's ABC1, not ABC, and this point is some other point, Q4. Then the firm is not going to be able to maximize profit at all because the firm's average variable cost is higher than the price. So the firm is not going to operate. So in this case, there won't be any profit maximization, which is why we have imposed this condition here that marginal cost equal to P star is equal to or greater than average variable cost. Okay, I'm deleting this because otherwise people who read the notes will get confused. Oops. Okay, we go back to the question. So this was the question. So basically, B, C, and D, all three are correct because in this question we are not given what the average variable cost curve is looking like. So C or D both can be true. Either can be true, I mean. So P is equal to marginal cost, we already know. P is equal to or greater than and equal to average variable cost. Both can be possible for the condition of profit maximization. Okay, let's go to the next question. So in this question, you are given that there is a firm which is existing in a perfectly competitive market, and you're given the quantity in 1, 2, 3, 4. You can assume this is in kgs or tons or number of thousands of good or whatever. Just take the quantity at face value for now. The fixed cost is fixed at 10. Marginal cost and average variable costs are given to you in the table, which you can read. The question is asking that if the market price meaning the market price is equal to 5.5, what will the firm do? The firm will produce at Q is equal to 6 or 4, or will it shut down, or is the answer indeterminate in this question? So based on whatever we have discussed right now, I want you to like just give it a little bit of thought, and then we'll discuss what happens.
Madam, can you please show the slide once again of the last solution that we got of question 2?
I didn't hear you. Someone was saying something.
Can you please once show that diagram that you drew for the question 2?
The diagram. Okay, 1 minute. In this one.
No, that's the second one.
Okay, so you have to mute yourself after you speak, otherwise I get feedback from. So I've uploaded the slides in the shared folder. You can look at the slides if you want to see the question.
Madam, I'm Krishna here. Uh, just for my understanding, hello, madam, can you hear me?
Yes, I can hear
Yeah,
you. Yes.
just for my understanding, for any firm, the given things are one is marginal cost, average cost, and the equilibrium. P star is the equilibrium price. Am I correct?
Yeah, in you can say it is the equilibrium price or market price because we're talking about perfectly competitive market.
Yes. And
Yeah.
there is another curve, no, fixed cost curve, one line fixed cost curve. How do you plot it on the same thing?
You
Because
can.
yeah, basically I'm trying to reflect on the various cost, fixed cost, variable cost, and total cost, and marginal
um,
cost. All that thing, if you can represent in one thing, so that I can visualize which is above, below. So just as a pure,
So
because I'm
fixed
not.
cost, you can just draw it as a line. So if this is the cost, this will be your fixed cost. Fixed cost
Yes,
is constant
yeah.
at one value.
So fixed cost, so variable cost is always above the fixed cost, correct? And total cost is fixed cost plus variable cost or average variable cost. Okay. Yeah. So total cost will be above AVC, correct?
Total cost will be above ABC. Yes. So we are actually. So actually, you're talking about two different terms. We are talking about average variable cost and variable cost. So total cost is fixed cost plus variable cost.
Oh,
Average variable cost is variable cost divided by quantity.
okay.
I'll come to what we compare with what.
Okay. Okay.
Yeah.
Because mathematically, I'm a little gray in these fine differences between marginal, variable, and fixed. Maybe we take some a pause and then clarify so that, because everything depends on this only. The entire economics depends on this. So okay, yeah, maybe some kind of a small tutorial on all these costs, the fine
It's
differences.
actually there in the lectures. If you have watched the lectures of Professor Vimal,
Yeah,
so
sure.
he has explained it in the lecture videos. I mean, I'm like generally what we do in the tutorial class is to take questions and explain through questions. Like if you want the entire concept overview, it's actually there in the lectures. I mean, he's explained it well. That's why I'm saying that. So if you want, you can watch the videos if you've not done that already. And he's explained the whole breakup of all the different costs in the videos, lecture
Okay.
videos.
Okay, madam. Sure. Thank you.
So I'm just reiterating the question. This is the question. You're given the marginal cost, average variable cost, and fixed costs. Quantities are as given, and you are asked what is the firm going to do given this cost structure and the knowledge that market price is 5.5. Okay, so let me just recap whatever we have done as far as costs are concerned. So total cost is variable cost plus fixed cost. For example, it can be something like 2q square plus 3q plus 5. I'm just giving an arbitrary example. This is not an actual function from somewhere. Like it's going to be something like this. Then this is your variable cost because it is varying with quantity. Variable means varying with quantity. And this is the fixed cost because it is a fixed number. It is not varying. Right? Now, average variable cost is variable cost divided by Q. So in this case, in our given taken example, is going to be 2Q plus 3. Marginal cost is dTC by dQ. It's the first order derivative of total cost, which is going to be 4Q plus 3. Or you can also think of marginal cost as the cost associated with producing one more unit or the next unit when quantity is Q. So these are all the terms we use. I don't think we are using any more terms in perfectly competitive market. Firms are price takers. Therefore, price is exogenous. This is important because we will come to competition and monopolies and oligopolies and game. I don't think we do too much of game theory, but a little bit of competition. In which case, the firms have the freedom to set their own prices. So that changes the dynamics, which we are not talking about right now. What we're talking about is that the price is given, market price is fixed at whatever it is, and only decide whether to produce or not and what quantity to produce. That is the only decision the firms are taking. So what I was discussing was that, say, suppose this is a typical firm, this is Q, this is P, and the firm has a marginal cost like this, and the firm is sort of having an average variable cost like this. This is marginal cost. Then the firm has to decide whether to produce or not, and if so, at what at what point should the firm be producing. Now, if you see that average variable cost, now let's not worry about this particular function which I have taken because that function is just arbitrary. It's not sacrosanct in some way. At this point, marginal cost is higher than average variable cost, and we assume, say, the price is somewhere here. So this is P star. Then at in this area, price marginal cost is higher than average variable cost, and in this part, marginal cost is higher than price. So obviously, in the part where marginal cost is higher than price, the firm is definitely not going to produce. In this part, where the marginal cost is lesser than price, and it's above the average variable cost, that is where the firm is typically going to produce. And that is because unless the firm is recovering its average variable cost, the firm cannot actually operate. So in this part, in this region where the average variable cost is higher than even the marginal cost, it means that it is too difficult for the firm to even recover its variable costs, forget about the fixed costs. So here the firm is definitely not going to operate. So now this is like just a recap of whatever is already there in the lectures. I think this is there in lectures 116 and 117. if I'm not mistaken. I was just reviewing what is in the lectures. So if you want a detailed explanation, it is there in the lectures, but I'm just recapping it here for your to refresh your memory. Now, let's come back to our question. In our question, we are given that the price, market price is equal to 5.5. Now, let's look at where all the firm has price of 5.5 in our example. So here you have marginal cost is 5.5, and here also you have marginal cost equal to 5.5. Now, if you look at average variable cost is always higher than 5.5. The lowest value of average variable cost is 6. This is the lowest value of average variable cost, which means that in this entire um, you know table, the whole table with all the different quantities, average variable cost is always higher than the marginal cost, right? This maybe in this part, let's say in after 6, let me use some other color. Let's try. I don't know if it will change. So yeah, let's go after this point. After this point, average variable cost is lesser than marginal cost. But before this point, before the point where quantity is 7, beyond quantity equal to 7, this is Q is equal to 7, beyond Q equal to 7, average variable cost is lower than marginal cost, but before Q equal to 7, in all these places, in all these values of quantity, average variable cost is higher than marginal cost. So that means the firm is not going to be able to recover any of its costs if it operates at a market price of 5.5, right? Because the firm can operate at P equal to 5.5 because marginal cost is 5.5 hypothetically if you ignore the average variable cost clause, but that is not possible like we were just discussing. Now, if you look at this diagram which I have made, what we are talking about is this part of the curve. In our given example, we are in this part of the curve. So if I were to say mark, we are somewhere here. Say suppose this is P is equal to 5.5. No, this is actually not P. Let's change the name of this thing. So this is P. But where we are, it's maybe somewhere here, something. Yeah. So this is the value given to us. Okay. I mean, it's not very neat, but the diagram is like that. I can't make it neater than this. So in this part, you can see that this is intersecting. What we are given is this is 4 and this is 6 in our case, and this is 7. Okay. For the values of Q equal to 4 and Q equal to 6, marginal cost is equal to price equal to 5.5 in the given example. At Q is equal to 7, marginal cost is equal to average variable cost, right? Which is what is happening. And at Q equal to 7 in our diagram, let me change this to some other color because this is ugly. I think you understand what I'm trying to draw. It's just so let's say this is the P equal to 5.5 line, this yellow line. Okay, so in our case, in this entire region where marginal cost is equal to P equal to 5.5, marginal cost is lower than the average variable cost. Now, the importance of average variable cost is that for the entire quantity which you're producing, you should be able to recover the cost, right? Marginal cost is only telling you the cost of producing one additional good. It is not telling you the entire cost, right? Average variable cost is telling you the entire cost, meaning like the whole cost of producing Q is equal to average variable cost into Q plus fixed cost, right? Am I making sense? Total
At
cost.
equal to 1 also, marginal cost is equal to average variable cost, madam.
Sorry, what?
At Q equal to 1 also, marginal cost equals average variable cost.
Yeah, well, okay, 1 minute. Where is this? Q equal to 1. Okay, that may be true. I mean, I'm not sure exactly. I've taken this table from somewhere, so I've just taken it as it is. So in this, you can see that it is decreasing and then it is increasing. I mean, if you're challenging me to draw the diagram and all, right, I can extend this diagram, but it could be some curvature may be different, right? I mean, you should try drawing these diagrams yourself so you can make sense of why the curve is like this. You can draw it like this. This is still your average variable cost. Maybe at some point here they're both the same. It can be like this. It just depends on the functional form, right? I have not drawn the whole thing exactly the way it is given in the table because that is a little bit difficult to do. It's difficult to label it. But is what I've drawn, is that making sense to you?
It is making sense, but it's also confusing if you are straying from the table.
Sorry, what?
Since we are straying from the table by not including.
We cannot string. Okay, if you want to do that, why don't you draw the diagram yourself? Actually,
Okay.
try drawing the diagram yourself. No, because you have to understand that I'm just trying to show it pictorially. We are not given the functional form of these things, right? I'm just showing it a representative thing.
Okay.
This is the average variable cost now.
It's not like I'm challenging you, man. Just said
No, I'm trying to tell you that if you draw it yourself, you will understand why it is like this. There is no contradiction in what I have drawn versus what is in the table. Right?
Okay.
At some point, say suppose this is not 0. Let me shift this a little bit. Say suppose this point where it is happening is 1. Okay, it just makes the diagram very messy. That's why I'm not doing it. So at some point, say suppose, let me redraw this actually, since you are not convinced about it. Because only when you draw these diagrams yourself will you actually understand that there's no contradiction in what is drawn. Okay, so say suppose this point is 1. They're just two different parabolas with different curvature, that's all, right? So they can intersect at 2 points. Now at point 4 and where Q equal to 4 and Q equal to 6, price is equal to 5.5 is equal to marginal cost, but marginal cost is still lower than the average variable cost. The point I was trying to explain was that marginal cost is the cost of producing one additional good, right? But it is not going to give you the total cost of producing quantity Q, right? It is going to tell you from Q to Q plus 1 or Q to Q plus 1 into 1.1 or whatever. It is going to tell you the cost of producing one more quantity of good, one more unit of good. But the entire cost of producing quantity Q is going to come from average variable cost into Q plus the fixed cost, right? Now, whenever the firms are operating, at the very least, they need to recover their variable costs, even if they can't recover the fixed cost. Sometimes in the short run, they may not be able to recover the fixed cost, but variable costs they definitely have to recover, right? So that is why in this part, which is there in the question, in this part, the firm is not going to be making any profit. Only when marginal cost is above the average variable cost curve, in that part, you can say that it is actually going to recover the variable cost and clock some positive profits. For example, if the price for P equal to whatever green line I've drawn, instead of the yellow line, say suppose this price is P equal to 9 or something like that. In that case, this is not 9, let's say P equal to, say, 7.5 or something. Say P is equal to 7.5, for example. Then in this case, you may get some value at which the firm can make positive profit. But in this case, in the question that is given to you, I'm saying it may. I'm not saying it will, but it may. But in the case which is given, the price is very low. Price is 5.5. Therefore, the firm is going to shut down. The firm is not going to operate at all. That is, that is what the question is asking. So, is this clear now? What you were asking me?
Yes, ma'am.
Okay. So let's go to the next question.
Madam, does it mean that the firm will just shut down without producing anything?
Yes, it means that the firm will shut down. The firm will not produce anything.
Okay.
Okay, let's go to the next question. In this question, there are two firms in an industry, and firm 1 produces with the total cost function given as this, and firm 2 produces with the total cost function given as the second term, TC2. They are both existing in a market with perfect competition. Define the supply functions of both the firms in the short run. This is a question from this book which Professor Vimal has recommended in the lecture videos, Andrew Scotter. This is chapter 14, question 4. I think this is an unsolved example in the book. So, before I jump into the question, first thing we will do is that we will need to check at what points both the firms are going to be operating. So we have the total cost functions of both the firms. We know we can find out the marginal cost functions, we can find out the average variable cost functions of both the firms, and we can find out at what points will both the firms be operational and at what points they will be maximizing the profit. I mean, we'll come to profit maximization a little bit later. For now, we're just being asked what are the supply curves. Supply curve, okay, I didn't mention this before, forgot to mention, but basically the supply curve is the part, let me explain in this diagram only. It is the part of the um, marginal cost function, marginal cost curve, which is above the average variable cost. So this dark blue part, which I've done in a thick line, that is your supply curve. So supply curve is defined only as that part of the marginal cost curve which is above the average variable cost curve. Okay, so now keeping this in mind, you have to find out the supply curve or the supply function for both of these firms first, and then I think there's second and third part also. Oh yeah, second part also to this question. We'll come to that later, but let's first do this first part. So I'm muting myself for a few minutes. You can read the question and try to solve it, and then we'll come back to it. Okay, so what do you think we will do in this question? Did anyone attempt the question so far?
Madam, first I think we had to compute marginal cost curve of each by differentiating the total cost with respect to Q, and then also compute average cost of each by dividing that function by Q. Sorry, uh, yeah, the average cost is dividing the variable cost by Q. So these two we can compute straight away.
Mhm.
Then then you said the supply is. Then I'm thinking.
Yes, so first we will compute the average variable cost curve. So average cost is just the total cost by Q, but average variable cost is the um, uh, the part where which is varying with quantity that divided by Q. So the reason why we take average variable cost is because we're talking about short run, and in short run the firms need to recover their variable costs. We're not talking about fixed costs right now. This is just how the question is framed, and also the part of um, the syllabus we are in. So, in short run, firms are going to optimize so as to recover their variable costs. That's why we are going to compute the average variable cost function first for both the firms, and we will see at what point the average variable cost is having their minimum for both the firms, and we'll set the condition for price as greater than the average variable cost. Okay, so this I think by talking too much it will sound confusing. So let me solve this. Okay, so let me write down the total cost functions. So TC1 is equal to 100 plus 2Q square plus 50Q. So this is TC1 and TC2 is okay. So first let's write variable cost for firm 1, or first write firm 1. Variable cost 1 is 2Q minus 4Q square plus 50Q. So average variable cost for firm 1 is just this whole quantity divided by Q. So this is 2Q square minus 4Q plus 50. So, okay, so what we will do is we will try to find. You can also factorize it, but the way I find it simple is if we can just factorize it like this only by rearranging the terms. So say this is q square minus 2q, and we can factorize this as q plus 1. So say this is plus 1 plus 50 minus 2. So we just added and subtracted 2 to the equation, nothing fancy. I added this 1 multiplied by 2, I've added 1 here, and I've subtracted 2 here. So 1 into 2 is plus 2, this is minus 2. Okay, I've just manipulated a little bit algebraically. This is 2 into q minus 1 whole square plus 48. This is average variable cost for firm 1. Just writing it in this kind of an expression basically tells you that at q equal to 1, average variable cost is having its minima. This is the minima of the function. If you want, you can also like differentiate it or factorize it or all that. This is just like a shortcut we can take. Now let's find the marginal cost curve or function. So the total cost is 100 plus 2 cube. 100 becomes 0. This becomes 6q square. Let me open the expression. Yeah, so this is 6q square minus 8q plus 50. This is the marginal cost curve. Similar to average cost curve, I'm going to factorize this also. And I'm going to take a shortcut again in this. Here, so as you can see, this is just differential. This is what we've done, dTC1 by dq. Okay, just explaining this in brackets. Okay, so here, let me say let me take 6 in bracket, q square minus 8q by 6, 8 plus 50. What should I add to this? Just 2q. Divided by 2 becomes 4, 6. So let's say this is, we add 4 by 6 here, plus or minus, plus 4 by 6, right? And here, this becomes 6, wait, I'm making use, no, 2 by 3. Sorry, I'm just thinking aloud. Don't get confused. You can just ignore me for a few minutes. I'm just trying to work out the maths. By 6, if I take 6 common, this will be whole square of 2 by 3. Okay? And this is a mistake. Okay, yeah, I made a mistake here. So this is going to be h divided by 6 is 4q by 3. Yeah, it's 4q by 3, so 2 by 6, 4 by 6. Yeah. 4 by 6, yeah, 4 by 6. And let me do the rough work this side. Q minus 2 by 3 whole square. It's going to q square plus 4 by 6, 9, 3, not 6. So not do this. Minus 3. What do we have here is this. Okay. This should be 4 by 9. Should be 4 by 9. Okay, so we have added this. 6 into 4 by 9 is what we have added. 2, 3, 8 by 3. So we will add, we will subtract 8 by 3 from here. Okay, let me explain now what I'm doing. I'm trying to make a perfect square here. So like I made 2q minus 1 whole square. Similarly, I'm trying to do a similar thing here. So I take, first thing I did is I took 6 common. You see, this is 6q square minus 8q. Where is my pencil now? This is 6q square minus 8q. In this, I first take the coefficient of q square outside. So in the bracket, I'm just writing q square minus 8q by 6. 8q by 6 is nothing but 4q by 3. Now, the coefficient of q tells me what the whole square might be. So, the expression a minus b whole square is equal to a square plus b square plus 2ab, or sorry, minus 2ab. I'm just trying to factorize it in this way. So if it is 2q by 3, that means 4q by 3, that means 2 by 3 is the is the other term, and that is why I put a whole square of that inside, which is 4 by 9. Now I'm just trying to simplify the term and adding equivalent quantity. If you're not convinced about this, you can try some other method. I'm just taking a shortcut so we are not wasting time on again taking a partial derivative and blah blah blah. It's 2 by 3 whole square plus, now I'm just leaving this as 50 minus 8 by 3. You can compute whatever this comes out to be. I think did it 6 into 4 by 9. I made a mistake. Yeah, this is fine. Yeah, 8 by 3 is correct. So 50 minus 8 by 3 is what? Hmm. This is a little bit cumbersome, the calculations, but I mean, that is not hopefully going to be the type of questions you get all the time. So this becomes 47.33. So this becomes MC1. Or I can leave it like this. We'll see later that this will actually be useful. Okay, so let's come back to where we were. So for firstly for firm 1, we've computed average variable cost curve and the marginal cost curve. Okay, now we see that both these functions reach their minimum at respectively q equal to 1 and q equal to 2 by 3, which means that average variable cost curve is to the right. And let me draw this. This is a rough diagram. Okay, now please don't pick on me for drawing this diagram, because this is not perfect. I'm just trying to tell you why we are doing this kind of factorization and all that.
Maybe, madam, simply the derivative of MC1 with the Q setting equal to 0 is much simpler, madam.
That if you find that simpler, you can do that. I just think this is easier for me. It is. I find this like easier generally. Then this MC1 is like a little bit complicated, but usually it is not so complicated. So if you find it easier to do it that way, please feel free. You can do it that way. So this is MC1. This is reaching its minimum at 2 by 3, and this is something like this, average variable cost. This is reaching its minimum at 1. Okay, so I'm drawing it so that you can see visually what we are trying to do, why we are factorizing it, and why we are trying to find the minimum of both the curves. So if the minimum of average variable cost is ahead of marginal cost, means after this point, if you plot after this point, marginal cost curve is already above the average variable cost curve. Okay, so here we have to find what this value is going to be. So this of the price, I mean this point, it's a very broken line. Let's call this as P star or something like that. P naught. Let's not call it P star because we're trying to derive the supply function. So P naught is this value. So what is that value going to be? This is Q equal to 1, meaning average variable cost is equal to, let me highlight this expression. So this is your expression. Now in this expression, if you put Q equal to 1, average variable cost comes out to be 48, right? So this value is 48, which means that for the firm to operate, P must be greater than P naught. For firm 1 to operate, P must be greater than P naught, which is equal to 48. Now, let me see what is happening. Okay, there's one, let me modify this diagram a little bit, because if you see at Q equal to 1, marginal cost is also equal to 48. So it's actually something like this. Not very proper. Okay, it's just something like this. It's just okay. So if you see at Q equal to 1, now let's look at the marginal cost curve. This is the marginal cost function. At Q equal to 1, marginal cost also comes out to be 48. I think let's compute this. At Q equal to 1, marginal cost comes out to be 6 into 1 minus 2 by 3 whole square plus 50 minus 8 by 3. Now this is what? This is 1 by 3. So this is 6 upon 9 plus 50 minus 8 by 3. You can simplify this. This is what? Plus minus whatever. 6 minus 3, 8 into 3, right? 8 into 3 is 24 by 9. 18 by 9. Wait a minute, there's something wrong. Hang on. I need to check. I made a mistake somewhere. This, let's put this as this was 47.33. Should be computed. Let's resolve this whole thing again. So this is this comes up to be roughly equal to, actually not roughly, it will come out to be exactly equal to 48, which is why I modified the diagram. Now, if you see that in this particular case, it is happening such that the marginal cost curve is intersecting the average variable cost curve at the minimum of the average variable cost curve. Okay. Okay, so here you see that the blue curve which I've drawn is intersecting the average variable cost curve at its minima. So basically, beyond the minima of average variable cost, beyond the minima means to the right of the minima, meaning if you increase quantity beyond the minima, the firm is going to be maximizing profit as long as price is higher than this P naught value. So therefore, we were writing P is greater than P naught equal to 48, right? Now, how do we get the supply curve for the firm? To get supply curve, we do MC1 is equal to price. Okay. Here, come back to this curve. Here, you see the marginal cost curve relation here. In this, instead of MC1, we just write price P. Okay. So, just one second. Yeah, I thought I made a mistake, so I was just checking. No, I'm correct. I'm not making a mistake. Okay. Now I was afraid that I thought the answer was actually option C, but the option C is not the answer, I think. So that's why I was thinking I made a mistake. Okay. So in this case, now this is pretty simple. If marginal cost equal to P, we just plug this value in here and we write P is equal to 6 Q minus 2 by 3 whole square plus 47.33. Okay, now in this, we just rearrange the terms so as to express Q in terms of P instead of P in terms of Q. Now, in this expression, what we have right now, this is also the supply curve, but this is an inverse supply curve because we are writing price as a function of quantity. What we are asked is the supply curve, which is quantity as a function of price. So what we will do is we'll just flip this. So let's first start by bringing this term to this side, dividing it by 6. Okay, this is Q minus 2 by 3 whole square. Then we bring it this side, Q minus 2 by 3, and we take under root E minus 47.316, and then we just take this 2 by 3 on the other side. For E greater than 48, than equal to 48. So this condition also you have to remember. I mean, it's not there in the question, but this you still should remember this condition. So let me just see if that is the answer. Okay, I don't know where my mouse is. Something wrong with my mouse. Okay, so that is the answer which is given. So now I think the mouse is not working. Perfect. Okay. Anyway, so let's do it for the other firm also, firm 2. So this is firm 1's supply function, what we have evaluated. Firm 2, you will do the same thing. First, let's express the variable cost. Variable cost 2 is variable cost 2 for firm 2 is 2 cube. Okay. Then average variable cost 2 is 2q square minus 8q plus 20. Okay. Then let's write the, or let's, before we write that, let's factorize this also, q square minus 4q, 4 plus 2, and this is 20 minus 4. Right? Just make sure it's correct. Oops. 2 plus 4 minus 8. So average variable cost is 2 q minus 2 whole square plus 12. Marginal cost for firm 2 is, I'm differentiating. Fixed cost term is anyways always 0, so I'm just differentiating the variable cost equation. So 6q square. So again, if you want, you can, factorize differently, or you can just take the partial derivative or whatever, whichever way it makes sense for you. I just prefer to do it this way. This is plus 20. In this, I will subtract something. So 16 by 6 is nothing but 8 by 3, and 8 by 3 is whole of what? Yeah, so what are we doing? 16 by q, 16q by 6. I was doing this rough work here. Yes, you can simplify it. 16 by 3. And this, again, we can simplify that. This comes out to be. Okay, so now we can see that the minima of the average variable cost curve of firm 2 occurs at q equal to 2, and the marginal cost function has its minima at q equal to 4 by 3. So this is again a similar kind of structure, but the values at which this minima is occurring is different than what it is for firm 1. So let's say this is the marginal cost curve, and let me see what is the value of both the functions at q equal to 2. Sorry, yeah, q equal to 2. This is 6 minus 4 by 3 is 2 by 3 whole square is 4 by 9. So this will again come out to be the same thing. So let's draw the average variable cost curve. Let's assume this is the minimum. This is 2. This is, okay, again I'm drawing a very rough diagram. It is just for representation purpose and just to understand what we are doing here. This is 12. Right? Yeah. Yeah, so this is what we have done. We've again factorized both the functions. At q equal to 2, the average variable cost for the firm is at its lowest, which is equal to 12. And the marginal cost at q equal to 2 is the same as average variable cost, which means the marginal cost curve is intersecting the average variable cost curve at that point, at its minima. Okay, and I mean, you can, if you want, you can mathematically verify it also. So this is generally going to be the case. I mean, whatever you do. So the marginal cost curve has its minima at 4 by 3, which we have checked. The condition for the firm to operate is P is greater than or equal to 12. This 12 is the, you know, what we found as this point. The marginal cost curve is intersecting the average variable cost curve. Okay. So we now need to write the supply curve for supply curve. Again, we will do marginal cost is equal to P. So we just plug in this value here. Instead of MC2, I will just write P equal to this whole expression on the right hand side. P is equal to 6 Q minus 4 by 3 whole square plus 9.33. We do the same kind of thing which we did before. We just rearrange the terms. Oh, sorry. We bring this to the other side. So we just brought q minus 4 by 3 to the left hand side, and we can remove the square here by putting the root sign here. So this is p minus 9.83 divided by 6. This gives you p minus 9.33 by 6 plus 4 by 3 for p greater than or equal to 12. So these are the two supply functions. Okay. All we have done is we have calculated the average variable cost curve, the marginal cost curve for both the firms, and we have checked the condition for the firm to operate, which prices the firm is going to operate for, and we found, we know that the marginal cost curve intersects average variable cost curve at its minimum, which is why we try to find the minima of the average variable cost curve, because to the right of that point, or that minima point, you can see the diagram, to the right of that point, marginal cost curve is above the average variable cost curve. Okay. So we compute that point, and that point, the price you get, which is this P equal to 12, that is the lowest price at which the firm is going to operate. In this case, firm 2, that is P equal to 12, and for firm 1, that was P equal to 48. Okay, so there's a big difference between that pricing for firm 1 and firm 2, which is sort of like the main key point of this question. So we found that price, and then we just use the marginal cost curve function or relation to rewrite it by replacing marginal cost with P, and we rearrange the terms algebraically to express Q as a function of P instead of P as a function of Q, and that gives you the supply curve. If you want, you can write this as Q2 and this as Q1, so there's no confusion. Okay, so let's go to the next part of this question. We've done part 1 of question 4. The second part, okay, let's see what answer we're getting. So the answer is option A, which is what we found as, what we calculated as the answer. So let's go to the second part. And the second part of the question is the same cost structures, everything. Now it's asking, at price P equal to 25, what is the short run market supply? And at P prime equal to 55, what is the short run market supply? So this you can easily compute after we have calculated the supply functions. So I'll give you a few minutes to compute this, to compute both the answers, and then tell me what you got as the answer.
Madam, short-run market supply for which firm? Because we have two equations over here.
Yeah, so the question is always saying what it is asking. Market supply for both the firms. You have to see which firm is going to be supplying, right? That is the whole point of the question.
Uh, Madam, when you say market, I think both the firms to be added up, right?
Yes. Okay, so let's see what happens when P is 25 and 55. Now at P is equal to 25, which firm is going to be operating in our case? So we see that for firm 2, the condition for operation is P is greater than or equal to 12. And for firm 1, the condition for operation is P is greater than or equal to 48. So that means at P is equal to 25, only firm 2 is going to be functioning, right? At P is equal to 25, only firm 2 is operational. Therefore, Q2 is 25 minus 9.33 by 6 under root plus 4 by 3. So you can calculate whatever this comes out to be. And next is at P prime is equal to 55. Both the firms will be operational. This is equal to QS, market supply. Q1 equal to 0. Okay. For P prime equal to 55, QS is equal to Q1 plus Q2 because both the firms are operational. So we will compute Q1 using the formula given, and then you will compute Q2 and you sum it up. So just writing it, but if you so you can just calculate these values, sum it up, and see whatever it's coming out to be. Okay, I'm not calculating it. You can calculate it and check what the answer is. It will be one of these options which is given. I don't remember which option is correct, but it's going to be one out of either A or B. It will be one of these two. Okay. Okay, let's go to the next question. It's a very similar question to what we have already done. So this is just for your, you can say this is for your practice. You're given the cost function of the firm. You are asked the firm's short run supply curve, and you're given a price P equal to 115, and you're asked what is the firm's supply and what is the firm's producer surplus at this price. So again, I'm just going to mute myself for a few minutes. Please attempt the question because unless you try the question, you will not know whether you have actually figured out the method, if you've got the method or not. So this is a bit simpler because this is just one firm which you are like you have compute only one um, average variable cost and marginal cost, etc. And whereas the supply curve, which we have computed in the previous question, and at a given price, what is the firm supply? So please attempt the question, and I will mute myself and I will solve it after that. Okay, so has anyone solved this? Okay, if not, please solve it. You can do this as homework or you can do it just after the class. I want to take one more slightly different question. I think we probably have time for only one more question, although actually I have brought a lot of other questions also. So I have uploaded the slides anyway to the shared folder. I will cover whatever I can cover in this class today. Whatever is left, I will cover in the review class. So next week we also have a review class. It is on Friday from 4 to 6. Okay. There is a regular class on Saturday, and next week Saturday class is the last class because that is week 12. But there is also a review session on Friday, which is from 4 to 6 p.m., the usual time, but it's on Friday. So we have two classes next week on Friday and Saturday, and both are from 4 to 6 p.m. So on whatever is left from today's class, which we have not covered, I will cover this in the review class. And apart from the whatever is left from today, if there is any other question you have from the entire syllabus, you can ask me your questions. And I'll try to bring some more interesting questions for, from the rest of the syllabus. So we can just do a review for the entire syllabus, which is intended to help you with, if you're writing the exam, it is intended to help you with the exam. Okay, so I will solve question 6 now, and if there is more time, I'll do question 7. Otherwise, we'll do question 6 and we will end today's class. And the rest of it we'll cover on Friday. Okay, so question 6 is that there is a firm which has a production function given as f is equal to under root z1 plus z2. You're asked the supply function for this firm if, now you're given the condition that if input price for z1 is greater than the input price for z2, okay, and you are told that the price for the final good q, whatever it is producing, this is the production function, right? So just give me 1 minute. Yeah, so Z1 and Z2 are inputs, maybe like K and L. Okay, you can call it K and L, you can call it Z1, Z2, whichever way you like to call it. You are given, okay, I think I have not mentioned. So W1 and W2 are the prices of Z1 and Z2. Okay, this is W1 and W2 are the, you can say it is equivalent of rent and wages or something like that. I've sort of forgotten to mention it in the question, I think. But basically, W1 and W2 are the prices of Z1 and Z2. And the final good is Q, which you are producing. And that is numeraire. Numeraire means that goods price is normalized to 1. So we are taking P output price equal to 1. So let's solve this question, a slightly different question. Okay, now we are in the case where the inputs are nothing but perfect substitute kind of a relation, because what is f of z1 comma z2 is equal to q. We can say this is q because output is q is under root of z1 plus z2. So if you remember your producer theory and even your consumer theory, so this is the type of relation in which if we are given W2 is less than W1, then the firm is going to use entirely Z2 and no Z1. Why is that? Because they are perfect substitutes. Because basically the firm is completely indifferent between using Z1 and Z2, right? There's no trade-off like that, right? We've discussed this at length multiple times in the previous classes, so I'm not explaining it more. So here, then we can just write then the firm uses Z2 entirely and no Z1. Okay, so now what is the cost going to be for the firm? It's going to be W2 Z2, right? And what is the production function going to be? Q is equal to Z1 becomes 0, so Q is equal to under root Z2. Now we can just rearrange this to write Z2 is equal to Q square, right? From here, we can write the cost function as W2 Q square. This is your cost function. All I've done is put Z1 equal to 0 so far. That's all. I've not done anything else. If you wanted, you could have written C is equal to W2 Z2 plus W1 Z1, but because Z1 is 0, this expression vanishes. Okay. Now you have the cost function. So let's get the marginal cost function. Marginal cost is W2 W2 Q, and average variable cost function. If you want, you can also get that. That is W2 Q. Sorry, not Q2 Q. So that means average variable cost is minimum at Q is equal to 0. So for any value of Q which is greater than or equal to 0, the firm is going to produce, right? So that much, I mean, this is just a check. Okay, this is just something we are going to check. So firm produces at Q greater than or equal to 0. Now let us try to, my mouse is not working. Something is wrong. Okay, what are we asked? I'm just trying to open the question actually. The question is asking me, what is the supply function? All right. So supply function is nothing but plugging in marginal cost as equal to price, right? For supply function, marginal cost is equal to price. Now our price is equal to 2W2 Q, right? We can write P equal to 1 also if you want, like what is this asking? Yeah. So if you just take P equal to 1, which is given, this is given, P is given. We just rearrange the terms, that's all. So Q is equal to 1 upon 2W2. So this is going to come out to be your supply function given that P equal to 1. Let me see if that is the answer. Yeah, so one of the options is Q equal to 1 upon 2W2. So that is the supply function. Now in the case where P was not 1, for example, then this would just be Q equal to P upon 2W2. In our case, we are just given this in the same way. I'm not sure which book this question is from. I've forgotten now. I think maybe it is from Varian. But that is just how the question was set up. So this is your answer. This is your supply function. You can write QS here if you want to be more correct.
Madam,
Supply
how
function
did you get C equal to W2 into Q star, Q square, sorry?
we calculated, so from here Q is equal to under root Z2, right? This is the production function which is given to you. So you just square both the sides, you get Z2 equal to Q square. So you plug in the value of Z2 in the cost function, you get W2 Q square.
No, I was completely new to this thing when you wrote C equal to W2 Z2. I don't know how we are getting this. Can you please clear it?
How do you get the cost function? No, I'm asking you, how do you get the cost function?
Usually, cost function is written as WL plus RK when we write
Right.
it.
So if you write WL plus RK, and instead of L and K and write Z1 and Z2, and WLN instead we write W1 and W2, you get the same expression, right?
Okay, yes, madam. Now I understand.
Yeah, it's just different notation. That's all. So you may find like mostly you get L and K as the inputs, but you could also be just given x1 or x2, z1, z2, x and y. The notation is not important. The basic theory or the basic concept is what you have to sort of hang on to. We write WL plus RK, but traditionally you can write summation of WI xi. I is equal to 1 to n. You can write cost like this also, right? If there are n number of inputs, x1, x2, x3, x4, and they all have prices, input prices, w1, w2, w3, w4, whatever, then cost is equal to this. Unless you're given a separate cost function, then it's a different thing. But when you are given input quantities and input prices, this is how you write the cost function. So instead of x, you can use z, you can use y, you can use whatever you want. Generally, we use L and K for the sake of simplicity, but this is just as correct, basically. Okay. So we've not done anything complicated. We just derived the cost function in terms of Q instead of in terms of input quantity. We've derived it in terms of output quantity using the production function. Then we derived the marginal cost and average variable cost functions, and we checked the condition for the firm to operate. It will operate at all values of Q greater than 0 or equal to 0 also. And we basically just write marginal cost as equal to price to derive the supply curve, and we get this expression. Now in this, because we are given that price is 1, I mean, if you are not given, you will just write it as P upon 2W2, but because you are given, we write it as 1 upon 2W2 as a supply. Okay, so I think that is a wrap for now. I mean, there's one more part to this question. We derive, I think, the profit function or something. Yeah, so you're asked the profit function, but it'll take me a few minutes to solve this and I don't want to rush through it. So I'll do this part of the question and the rest of the questions. There are 2-3 other questions, and I think they're all kind of useful and interesting. So I want to cover this in the next class, which is going to be on Friday. Okay, so I hope you guys can make it to the review class also. If you have not received the official email for it yet, then you should receive it pretty soon. But even if you don't, I will post it in the discussion forum at the reminder, and the link for joining is going to be the same. There's no difference in the link for joining the class. Okay, all right. So I think we can end the class here. So I'll see everyone on Friday, hopefully. Thank you.